Hello guys, welcome to my YouTube channel. Welcome to this series of lecture on bioreactor design analysis. We have been discussing chemical kinetics and reactor design chapter. We have already discussed two videos. I advise you to go and watch that videos and then come back because we will be using some equations we proved earlier from our earlier videos. So we were discussing analysis of batch reactor data. As I told you, we can analyze the batch reactor data by two different methods. One is integral and the other is differential. So we were continuing integral equation. So in integral equation we did unimolecular irreversible first order reaction. We solved that reaction with integral method. Today we will do another type of reaction which is irreversible bimolecular second order reaction. Okay, so remember, this is a bimolecular reaction and this will be a second order reaction that we will talk about. Okay, so suppose we consider one reaction A plus B giving rise to products. Okay, this is a bimolecular reaction and by definition this is a second order reaction. So if we write the rate expression, what will be the rate expression for A? It is minus of dCA by dt, and for B it will be minus of dCB by dt. Alright, so Ca and Cb are the concentrations, molar concentrations. I'm just writing concentrations. Okay, so now another definition of the rate expression that could be written as it's minus of Ra by Na, okay, is equal to minus of Rb by Nb, okay, where Na and Nb are the stoichiometric coefficients of A and B. Okay, so now what happens here, 1 mole of A is reacting with 1 mole of B. Okay, so here Na is equal to Nb. If Na becomes equal to Nb, then we can say minus of Ra is equal to minus of Rb. So that means the two rate expressions are equal. If the two rate expressions are equal, we can write a single rate expression for both. So minus of Ra is dCA by dt is equal to minus dCB by dt, okay, is equal to K Ca into Cb, where K is the, sorry, I will write it over here, where K is the second order rate constant. Alright, so this is the picture till now. Now another thing, if you remember, in my previous lecture I showed you the fractional conversion. Xa is written as 1 minus of Ca by Ca0. Okay, so from here I can write Ca minus Ca0 minus Ca is Ca0 into Xa. Okay, and what is this Ca0 minus Ca? It is the amount that has reacted. Okay, amount that has reacted. So from here I can write Ca is equal to Ca0 minus of Ca0 into Xa. Alright, this is something. So similarly for B also I can write Cb is equal to Cb0 minus Cb naught XA. Now we are also hypothesizing here that we are starting with the same initial concentration of both A and B. So we are starting with the same initial concentration of both A and B and same stoichiometric coefficients. So same amount will be reacted. Alright. So I am writing it as same initial concentrations of A and B, same stoichiometric coefficients of A and B, so same amount would be reacted. Alright, so now what will happen, we can, this rate expression that we got, okay, this one, we can modify this. How? So minus RA, so minus RA, which is also could be written as Ca naught into dxa by dt. Alright, how? Because here we got minus of Ra is minus dca by dt, and we know from here, we know the relationship between Ca is equal to Ca naught minus Ca naught xA. So if we just substitute this over here, we get this expression. We take the differential and everything, we take this expression. So minus of Ra is Ca naught into dxa by dt is equal to K. Now we will use these two expressions, Ca naught minus Ca naught xa. This we are writing in place of Ca, and for Cb we will replace Cb naught with we will use Cb naught over here, but in the second Cb naught we will write Ca naught xa. Okay, so up to this, is it clear? This Cv naught we have changed it to Ca. Alright, so now we got this thing, so on the left hand side we have Ca naught dxa by dt is equal to K. We can take Ca naught common, 1 minus of xa, and from the second term we can take Ca naught common by force. So if we take Ca naught common by force, it will be Cb naught by Ca naught minus of xa. Yes, so one Ca naught will get cancelled. So we have dxa by dt is equal to K Ca naught K Ca naught 1 minus of xa into, okay, so this Cp naught by Ca naught, we are taking this as another term called as the m, just for our writing purposes. So we can write it as m minus of xa. Okay, so now what we can do is we can take this thing to the left side. So dxa by 1 minus of xa into m minus xa is equal to K Ca naught into dt. So now as usual we will take integration. So at time equal to 0 we have 0 fractional conversion, at time t equal to t we have the total conversion, which is xa. So if we integrate this, we will get somewhat expression like this one, ln m minus xa by m into 1 minus of xa is equal to Ca naught m minus 1 into kt. Okay, so this is the final thing that we will get. So see here, this is of the form of y equal to mx. So if we draw this, what we will get? We will get, so if we draw this ln m minus xa by m into 1 minus of xa. So it will be on the y-axis and time will be on the x-axis. So it will be a straight line passing through the origin. So the slope, what it will be? It will be this thing. This thing will be the slope. Okay. Ca naught m minus 1 into k. Alright. So this thing that you will get, and if you want to put the value of m, specifically the slope will be cb naught minus ca naught into k. So this is all about irreversible bimolecular second order reaction when you have two different reactants A and B. Okay, so in our subsequent lectures we will see some more videos where we will discuss some other types of reactions and how to solve them for batch kinetics. Thank you.
So if you like our videos, please do support us. As you know, this YouTube channel is not been monetized yet. So if you want to support us, you can scan this QR code on any UPI app, whether it's Google Pay, Phone Pay, Paytm, whatever UPI app you use. You can scan this Google Pay and send us whatever contributions you are. We assure you your small contributions will be significant in boosting this YouTube channel, and it will help us to improve our videos in future. So alternately, you can use this UPI ID. You can type this UPI ID, you can open your UPI app, and here you will get the UPI icon on the home screen of the UPI app. So this interface will show you the pay UPI ID or number. You can type this UPI ID and you can pay us whatever contributions you like. Your contributions will be beneficial in growing this YouTube channel and bringing the best of the YouTube videos to help clear your concepts in biotechnology.